What's up, class? It's Mr. Wicklehouse, and today in our matrices unit we are talking about the determinant and the inverse. Alright. So the determinant, what is it? It's a value that is used to find the inverse and or to determine if the inverse matrix exists. Alright. So, if we have a 2 by 2 matrix, then we can find the determinant for a 2 by 2 matrix. And in order to do that, then I take this A and I multiply it by D, right here, A times D, and then I would subtract the number that comes from multiplying B times C. Okay? So let's do one here. So here's matrix A. Matrix A is this matrix. Okay. I'm looking for the determinant of A. If you see this letter A inside of these two lines like this, and you're talking about matrices, this does not mean absolute value. This means the determinant of that matrix. Okay. So you could see the determinant written like this, and it might say determinant A, or it would be two lines like this, it'll be determinant A. Alright. In any case, we have to multiply A times D. So here's A is 3, so I plug that in for A, and D is negative 4, so I plug that in for D, negative 4. And then I'm going to subtract B times C. So here's C, and here's B. So I take B, plug it in, these got flip-flopped around, but it's the same. So 2 times negative 1, and that would be B times C. So 3 times negative 4 is negative 12. Negative 12 minus 2 times negative 1 is negative 2, so that's negative 12 plus 2, and that's equal to negative 10. The determinant of matrix A is not 14. Don't know where that came from. It is negative 10. Okay? Alright. So, what that means is, when we find a determinant that has some number with it, it means that we can find the inverse. In other words, the inverse exists. Okay? There's only one situation where the inverse of the matrix does not exist, and that is if the determinant is 0. Okay? Alright. Anyway, let's do a couple examples here. Hopefully. And we're out of focus again. Hold on. Get it into focus for us. Hopefully. There we go. Alright. So, here we've got matrix A, and here we've got matrix B. Well, we're looking for the determinant of A. So we're going to do A times D minus B times C. So A is negative 2, D is negative 1, minus 3 times 0. Negative 2 times negative 1, that's going to be 2. 2 minus 3 times 0 is 0. This guy is equal to 2, which means that the matrix inverse exists. Okay. Let's find the determinant of B now. Same idea. A times D minus B times C. So negative 5 times 4 minus negative 2 times 3. This is negative 20 minus negative 6, which is going to give us plus 6. That's going to be equal to negative 14. That is how you find the determinant. Alright, moving on. Let's talk about finding the inverse. So, inverse rules. There's some rules here. Due to the process of finding the inverse by hand, an inverse can be undefined. In other words, it doesn't exist. Okay? The two circumstances where the determinant does not exist would be, or rather the inverse does not exist, would be that if the determinant was 0, remember before I said that if the determinant was 0, then there would not be an inverse. So remember, if the determinant is 0, no inverse can be found. It doesn't exist. It's undefined. Alright? Or we can't find an inverse if a matrix is not a square matrix. What I mean by that is, remember we talked about dimensions of a matrix and how they're and matrices are kind of rectangular? Well, if the rows and the columns don't match, then it's not a square matrix. Okay? So, for example, find the inverse for the following matrices. Well, here's this matrix. Is this a square matrix? Well, 1, 2, 3, that's got 3 columns and 2 rows, not a square matrix. So, there's no inverse. Can't find the inverse for that. Okay? Now here's this one. Is this a square matrix? Well, 2 rows, 2 columns. Yes, it's a square matrix. Okay, let's find the determinant. So the determinant of this is going to be 1 times 4 minus 2 times 3. Okay, well that's 4 minus 6 equals negative 2. Okay, so yes, this has an inverse. Alright, so this matrix has an inverse. This one does not, because it's not a square matrix. If I had gotten 0 on this for the determinant, then it would not have an inverse either. Okay? Alright. Moving on. Let's talk about how to find an inverse. So, to find an inverse of a 2 by 2 matrix. So make sure that the matrix is a square matrix. We already kind of talked about that. Okay? This is true for any matrix, not just a 2 by 2, but we're going to do 2 by 2s by hand just because we can do them by hand pretty easily. Okay, after you make sure that it's a square matrix, so this one is 2 by 2, then we find the determinant. Okay. After we find the determinant, we're going to use this formula right here to find the inverse of the matrix. Okay, so the determinant of A equals 3 times 5 minus 7 times 10. Okay. That's 15 minus 70. That's equal to negative 55. Okay. Now let's find the inverse of A. Alright. So, what I do is I do 1 over negative 55, because this right here, this number right here is going to be the determinant. Okay. Then I'm going to move some things around here and change some signs. So D moves in the place of A, 3 moves in the place of D. So I flip A and D around. Then I flip B and C around, so this is 7, this is 10, and I change the sign on those. Alright? Okay, now that I've done that, I'm going to multiply this through to each element in this matrix, and that's going to give me my inverse. So I do 1 over negative 55 times 5. That's negative 5 over 55. We'll simplify this here in a minute. Negative 10 times 1 over negative 55. That's going to be positive 10 over 55. Negative 7 over 55, that's 7 over 55. 3 over negative 55, that's negative 3 over 55. Okay, simplify those. This is going to be negative 1 over 11. This is going to be, let's see, 5, that's 2 over 11, 2 over 11. This one's still 7 over 55. This one's still 3 over 55. There we go. There's our inverse. So A inverse is equal to this. Okay? That's how you find inverses. Now, let's do a couple more little examples here. Alright, what are we looking for here? That's right, we're looking for the determinant. So the determinant here is 3 times 2 minus 3 times 2. Well, that's 6 minus 6. That's equal to 0. Whoa, what? 6 minus 6 is 0. Determinant is 0. We've not had one like that. Can I find the inverse? No, I can't. Even though this is a square matrix, the determinant is 0. There's no inverse. So this was wanting us to find the inverse. We can't because the determinant is 0. This is another way to write determinant of B. Determinant of B is 0. Alright. Here's this. Alright. Is this a square matrix? Yes, it is. Let's find the determinant. We are trying to find the inverse of this. So we do 3 times negative 2 minus 5 times negative 4. That's negative 6 plus 20. That's going to be 14. Okay. So now I'm going to do the inverse. I didn't get 0 here, so I'm good to go on this. So 1 over 14. Remember, I flipped D and A around, and I flipped B and C around and changed the sign. That's going to be negative 2 times 1 over 14 is going to be negative 1 over 7. 4 times 14 is 4 times 1 over 14 is going to be 2 over 7. Negative 5 times 1 over 14 is negative 5 over 14. 3 times 1 over 14 is 3 over 14. I've already done all my simplification of all the fractions and stuff. There we go. So the inverse of C, which is what this was asking for, was negative 1 over 7, 2 over 7, negative 5 over 14, and 3 over 14. There we go. That's how you do it, guys. I will talk to you later.